Hi everyone, myself Nisha. Today I'll be presenting about environment as a service. Yes. Before we get into the session, let me just set the context with a quick question. Would you pay electricity bill for an empty house all year just to avoid switching it on and off? No, right. Most of us wouldn't because it is an unnecessary cost with no real usage. In the same way, across crowded open platform, we have non-production environments often remain running overnight and on weekends, despite of whether the environment is being used. That means we continue paying for those resources which are running 24 by 7 regardless of that the environment is being used. So the real question is, do we actually need those non-production idle resources running 24 by 7? In most of the case, the answer is no. But the challenge, however, is if we destroy an environment, we must be able to recreate it without losing consistency, like the same configuration, version, and less manual activity and more repeat troubleshooting. That's where ES comes into picture. It provides a controlled and repeatable life cycle that is snapshot, destroy, recreate, and validate. In this session, I will be covering about what ES is, the integrations it relies on, followed by an architecture, and the capabilities of ES, and we will do a cost comparison between 24 by 7 and on-demand operational model, observability, role-based access control, and followed by a demo. Moving to what is ES, it is a capability designed to manage non-production environments in a controlled and repeatable way. So the core concept is simple. Instead of running the environments all the time, we treat them as on-demand. If it is needed, we can deploy the resources, and if it is not needed, we can destroy them without losing consistency. In this slide, I have highlighted some of the core uses of ES. Starting with pay as you go. ES supports only when needed model. So the teams can pause the environments during overnight and on weekends or during inactive period, despite of considering shutting down as a risky manual activity. Number two, bulk deployment. Environments typically consist of multiple microservices, shared components, and dependencies. ES focuses on managing those applications as a unit. So either it is bringing up an application or taking it down is a single coordinated operation, not a series of manual steps. Number three, auditing. This shows what action has happened and how much it has cost, which helps the team to spot the waste like long-running environment and repeatable redeploys. So we can clean up and then schedule it better. Number four, observability. This gives a single real-time view on the environment status, visualization, and failures. So the teams can know what's happening, what's idle, and what's broken. And it also shows the operational context on who triggered the action and with drill-down per probability graph. So in short, ES helps to control cost, reduce manual operations, and improves the visibility and consistency. Moving on to the ES integration, in this slide I have highlighted some of the key resources ES integrates with, like OpenShift, GCP scheduler, cloud functions, cloud services, and database. There are a lot of other resources as well, depending on the platform needs, like CI/CD, source control, and registries, etc. Moving on to the ES architecture, this slide illustrates the end-to-end work of ES managing the environment lifecycle. We have developed the ES self-service plugin, which enables the users to deploy resources on demand and destroy it when it is not needed. When the user navigates to the ES plugin, we have two execution flows, manual trigger and schedule trigger. On the manual trigger, if we perform an action like deploy or destroy, for the GCP path, Tecton CE pipeline will be triggered to deploy the resources like cloud and services and jobs. And in the same way, GCP API will be called to destroy the resources. Coming to the OpenShift, we use Helm values or templates to manage the application state. So the key mechanism is adjusting the replica count. We will keep the desired replica count to deploy the resources and keep it to 0 to destroy it. Once the triggered action is completed, all these details will then be stored in the database, and the status of the triggered action will then be notified to the teams via email. Now, coming to the schedule trigger, we can configure the deploy and destroy time directly in the ES self-service plugin. and then the scheduled configuration will then be stored in the database, and the in-memory component catches the configuration at the trigger time. When the scheduler fires, it invokes the same deploy or destroy path as the manual flow. So every time an action is triggered, this flow will be repeated. That is it on the architecture. Now coming to the ES capability. In this slide, I have added some of the operational capabilities of ES, managing the environment, fast, cost-aware, and repeatable. Starting with the ES self-service experience, the main goal is to reduce the dependency on platform team for routine tasks. Instead of raising tickets and running long run books, we can directly perform the lifecycle action in the plugin itself. So the starting point will be consistent and standardized for everyone. The second capability highlighted here is bulk deployment. Environments typically consists of multiple dependencies, shared components, etc. With bulk deployment, the users can select a set of applications and deploy them in a single coordinated operation. Behind the scenes, this follows our pipeline standards and templates. The third capability is scheduler work on automation. This addresses the biggest day-to-day waste environments running idle overnight and on weekends. With scheduler, the teams can define the business hours directly in the UI, and when the scheduler fires, it invokes the same deploy and destroy path. So the behavior stays consistent and auditable for everyone. And the last capability is cost optimization report. We can view the cost optimization impact directly in the ES self-service UI, and the UI provides access to the cost optimization report, which is generated in the looker dashboard. Since the non-production environments are only needed during the business hours, shutting them down during the idle period can save a significant amount of cost. Moving on to the cost comparison, in this slide illustrates the common challenge in cloud computing, the cost implications of services running overnight and on weekends. Here we are comparing a traditional 24/7 operational model against on-demand, specifically leveraging ES in the Google Cloud platform. On the left, the red bar represents the weekly cost of a specific GCP environment, which is running for a full week. That is $230. This cost is subject when the service runs for a full week, that is $160. But as noted in the right, the actual need for this environment is 22 hours per week. That means this environment has not been in use for 156 hours per week. And if we calculate the cost for this 156 hours, that is $213. Now let's take a look at the green bar on the right, which shows the weekly cost of the same environment with ES. By switching to the on-demand approach that matches with the actual need. The weekly cost has dropped to just $16. This cost is only for the 12 hours per week uploads that matches with our actual usage of the service. So the impact is clear. ES eliminates the wasted expenditure in idle resources by transforming inefficiency into significant cost. This is just an example of a single environment using ES. If we apply ES across multiple environments and diverse resources, significant amount of cost can be saved. Moving on to the observability, every action ES performs like deploy or destroy is captured and stored in the database, along with the project information, the user who triggered it and timestamp. The same information is then exposed via the ES self-service UI. So the teams can know what's happening and what's the current state and who triggered it. It also shows the single real-time view on the environment status, which helps us to speed the troubleshooting. And this flow represents the ES database structure. When a destroy or deploy action is performed, either manually from the ES plugin or automatically via the scheduler, ES first records the last action details in the database. And then it executes the requested lifecycle flow in the target platform. Once execution is completed, the flow splits. On success, it updates the database as successful action, and on failure, it captures and stores the failure logs. Once the execution is completed, the status of the action will then be notified to the teams via email for troubleshooting. Moving to the role-based access control, RBAC in RIAS ensures secure self-service with least privilege and role-based access. The permissions are managed at the project level, so the teams can only able to deploy or destroy a scheduled environment they are authorized to, while we manage the GCP environment via Terraform. Overall, this provides a controlled self-service with accountability. And this flow represents how access is granted to the ES self-service plugin using the role-based access control. When the user logs into the ES plugin for the GCP environment, it validates whether the logged in user is part of the GCP admin friend group. If yes, permission will be granted, and same for the OpenShift. It validates whether the logged in user is part of the namespace admin friend group. If they are part of it, they will be having permission to perform the actions. Moving on to the demo on how we deploy or destroy applications in the ES plugin. The first step is to select the target platform. We can choose between GCP or OCP. For this demo, I'll start with GCP. Once GCP is selected, we need to select the specific project from the drop-down. Once the project is selected, the tool will auto-populate the list of applications that are present as part of the specific project. And we can also configure the destroy date and create date directly in the UI to schedule the trigger. And we also have an edit option where we can edit the details of the future schedule events. We can update the date and timestamp in this section. And we also have a history section where we can see the record of scheduled events along with the event date, the event type, and the user who scheduled it. And we have a deploy or destroy history where it shows the environment specific details like the configurations and status of the environment. And below that we have deployment information summary where it shows the last action details like last creation and destroy date along with the user information. And below that we have GCP environment status table which provides information on the cloud and services and jobs and the statuses of the triggers. And we also have we can also view the cost saving report by selecting the specific timestamp in the UI. And if we click on the report, it will redirect to the Looker dashboard. I did included the Looker dashboard as part of the demo due to confidential information. And once we click on the deploy, it will list all the applications that are present as part of the selected project. And upon confirming the deploy, the Tecton CD pipeline will be triggered to deploy the GCP resources. Once the Tecton CD pipeline is completed, all the resources will then be deployed in the GCP. I blanked the content due to the security information. And moving to destroy, once we select the destroy option, for the listed applications, the GCP API will be called and the resources will be destroyed from the GCP. All the resources will be deleted. Now moving on to the OCP, we need to select the OpenShift namespace from the drop-down. Once it is selected, we have the same schedule, edit and history option similar to the GCP. And if we click on the deploy option, it will update the health chart values to update the replica count in the OpenShift. As you can see, the pod count has been increased, that means the service is running. Now coming to the destroy option, once we select the destroy option, the ES will update the helm template values to keep the replica count as 0. As you can see, the pod count has decreased to 0, so that means the service is down now. For this demo, I have included only the manual trigger of the ES. This process, the same process can automatically happen if we schedule via the ES plugin. And To conclude, yes, not only simplifies the environment management, it also plays a very important role in the cost optimization of GCP and OCP. And we are also continuously working on further enhancement of the ESM service model, and it is a great opportunity to present it today. Thank you.
I can make a comment if you don't mind.
Firstly, want to compliment you on solving a very important problem. And just because we are here sharing knowledge and information, one of our customers about 2 years ago incurred $38 million infra cost as against a budget of 14 million global infra. Most of it came from improper configurations of non-prod and prod, all the VMs, unused assets, and teams not being set up, groups not being set up in the organizational layout of the hyperscaler. I don't want to name the hyperscaler, but this is such an important problem. And the other piece I thought was it would be valuable, especially when you're communicating with some of the senior leaderships. While the monthly cost is a good number, weekly savings is a good number, if you could annualize it, because all the leadership will look at that number. The cost is a very important number for any leader. So when you annualize it, it gives them a sense of where they are. Weekly and monthly cost doesn't give them a benchmark. But when you annualize, they can come immediately relate to their annual budgets, new budgets, and so on and so forth. Yeah? But lovely presentation. Good work. Thank you.